This is determining empirical and molecular formulas. So the reason I just went over calculating mass percentages is because when we find those, which you can find in the lab, you can actually figure out what the formula of your compound is. And that's what we're going to do here. So there's two kind of new vocabulary terms, and that would be the empirical formula and molecular formula you actually already know. So empirical formula of something is the lowest whole number ratio formula. So it would be like not what the molecule actually looks like, just all of their subscripts kind of reduced. So for example, if I'm looking at glucose, C6H12O6, 6, 12, and 6 are all divisible by 6. So its lowest whole number ratio would be 1 carbon to 2 hydrogens to 1 oxygen. So this is glucose's empirical formula. This one, what the actual molecule looks like, is its molecular formula. All right, so molecular formula and empirical formula. The reason I am telling you this is because in order to find the molecular formula from lab data, you first have to find the empirical formula. So how do we find empirical formulas? Okay, these are the 4 steps to solving an empirical formulas problem. So if I give you some percentages or some masses and I'm like, find the empirical formula of this compound, this is what you're going to do. Okay. Now, first of all, we are going to be converting things into moles because this 1 carbon to 2 hydrogens to 1 oxygen can be moles. So always convert to moles first. Now, if I gave you a percentage though, so look at example number 5, I gave you 17.6% sodium, 39.7% chromium, and 42.7% oxygen. What I want you to do is just assume that you have 100 grams, because we can't convert percentages, but we can convert grams. And if I assume I have 100 grams, then I have 17.6 grams of sodium, 39.7 grams of chromium, and 42.7 grams of oxygen. So we need to start with grams. So that's why I said assume 100 grams of sample. Now, if I already gave you grams, I didn't give percentages, you can skip that step. Okay, so next you need to convert your grams into moles. And to convert something from grams to moles, we know that we need to divide by the molar mass. So find that on the periodic table. Okay, convert your grams into moles. So now you'll have all of these mole numbers of all of the elements in there. So if we were doing this for glucose, we would have the number of moles of carbon, hydrogen, and oxygen. Now, unfortunately, these numbers are never pretty. We'll get numbers with a whole bunch of decimals, and so it's kind of hard to tell that this should be a 1 to 2 to 1 ratio. So how do we get it to whole number ratios? What you're going to do is take all of those mole numbers and divide them all by whichever one is the smallest number. That gets you to a ratio, because if you think about it, whatever one is smallest, then you're going to divide by itself and you would get 1. And then the other ones, if you divide by that same number, you should get a whole number. Now, if you don't get a whole number, say you got something 0.5, then that means you're going to have to double everything to get up to whole numbers, because whenever we have an empirical formula, these have to be whole numbers. You can't have like 1 carbon to 2.5 hydrogens to 1 oxygen. That doesn't work. Okay, so I'm going to go through step by step how to do this on example 5. You're welcome to try it by yourself first, but I am just going to jump in. All right, so I said start with each of these. Assume you have 100 grams. So I have 17.6 grams of sodium, 39.7 grams of chromium, and 42.7 grams of oxygen. I just put them all over 1 just so that I can watch my dimensional analysis. Next thing I do is convert to moles. So I get their molar masses from the periodic table. Sodium is 23.0, chromium is 52.0, and oxygen is 16.0. So I converted each of those to moles. Now, when you do that, the number in your calculator is 0.7652. 0.76352 and 2.66875. Notice none of those are very close to whole numbers. Now, if you got like 4.001, that's 4. Okay, if it's close enough to a whole number, go ahead and round, but these are not close to whole numbers. So I'm going to divide them all by whichever one is the smallest, which in this case is 0.6 or 0.76352. So that one divided by itself gives you 1. This one divided by 0.76352, you'll notice these numbers are very close to each other, gives you very close to 1, like 1.01 or something like that. So that's 1. And this one, when you do 2.66875 divided by 0.76352, you get about 3.5, which is not close to 4, not close to 3. It's right in between. So what I ended up with was a 1 to 1 to 3.5 ratio. Now I can't put a 3.5 in a formula, so what I'm going to do is to get rid of a 0.5, I would need to double everything. So I doubled that one, and doubled that one. So it's really a 2 to 2 to 7 ratio. So my formula is Na2Cr2O7. And that is your empirical formula. Okay, now in example number 6, I would like you to try to do example number 6 by yourself. Notice I gave you grams to start with, not percentages. So just start with the grams numbers. And I also left out the hydrogen mass, but you should be able to calculate it because I'm giving you 5 grams of starting sample. And then I told you how much carbon and how much sulfur. So the rest is hydrogen. Okay, so go ahead and give this a shot and see if you can get to the empirical formula. All right, so here we go. I started with my masses, 0.951 grams of carbon, cut that from there. Hydrogen, like I said, was whatever was left. So I did 5 minus the carbon and the sulfur. So I have 0.24 grams of hydrogen. And I told you I had 3.89 grams of sulfur. And so those are all masses. I converted them to moles. So I divided carbon by 12, hydrogen by 1, and sulfur by 32. Those are their molar masses from the periodic table. And I got 0.07925, 0.24, and 0.119. Of those 3 numbers, the smallest is 0.07925. So I divided this by itself, which gives me 1. I divided 0.24 by 0.07925, which gives me about 3, or very, very close to 3. Okay. And then I did 0.119 divided by 0.07925, and I got about 1.5, very close to exactly 1.5. So I need to get rid of my 1.5 and multiply all of them by 2. So this times 2, this times 2, and this times 2. So I have a 2 to 6 to 3 ratio. So it's C2H6S3. And that would be my empirical formula.